All right, let's take a look at processing the language of chemistry and types of reactions. So as a quick review, there are three types of reactions that we're learning about. One is when two chemicals combine, at least two, and the key is they form one product. The other is when you have one reactant and it splits into two or more things. And last is a bunch of carbons and hydrogens combining with oxygen and forming carbon dioxide and water. Those are kind of like the classic products. Okay, I'm going to switch colors here. And also, I just noticed this 2 was not a subscript, so I'm going to fix that on the original. Okay, let's get to it. Other helpful information, there are 7 molecules that are never alone, meaning if they're in combination with something else, that's fine. Like if Cl is with Na, it's NaCl. But if Cl is by itself, it always finds another Cl to combine with. And so it always gets a 2. It's never alone. So the way that you can remember that is it kind of makes a funny word, Hofbrinkel. And there's a special note here. We haven't learned how to balance reactions yet. Maybe you have in previous learning, but we're not going to focus on that until a later learning target. Okay. It's so simple, right? An electric car battery. Here's what we're going to look at. In the anode of an electric battery, the following reaction occurs. The key here is that there's one reactant breaking up into 3 things here. So this would be considered a decomposition reaction. And here we have 1, 2, 3 reactants combining to form one product. So that is a combination. Here is a little bit of a tricky one because technically this is also a combustion reaction. It's just a very simple form of it. I would accept combination as an answer or combustion. And in an internal combustion engine, octane reacts with oxygen to produce carbon dioxide and water. This is definitely a combustion reaction. Okay, so it says complete the following combination reactions. Hint, if ionic compounds form crisscross charges to form products, label the states of matter, but don't worry about coefficients to balance. Okay, so lithium has a +1 charge, and it's in a new relationship. It was single before. It's in a relationship with oxygen now. So we're going to crisscross the charges. We just made Li2O, and ionic things are typically solids, so we're going to label that with an S. Next, calcium's got a +2 charge, and it's in a new relationship with sulfur, which is a -2 charge. So those cancel out, no crisscrossing necessary, and this is another ionic compound. Ag always has a +1 charge, and Cl here would have a -1, and so this would just be AgCl. S for solid. Okay, for the decomposition reactions, it says break atoms apart and look for diatomics. Diatomics are Hofbrinkel. So here we would have Sr, solid, plus N, and it's never by itself, so it'd be N2, which is a gas. Next one, we want to break them apart. And then we know O is in Hofbrinkel. K would be a solid. And then break the next one apart, Na plus F. F is in Hofbrinkel, so that's going to get a 2. And Na will get an S. Complete the following combustion reactions. Hint, the products are always the same. CO2, gas, and H2O, liquid. CO2 gas plus H2O, liquid. Complete each equation and identify what type it is. So for the first one, we've got one reactant. So this would definitely be a combination. And, oh, I'm sorry. One reactant, it's the only thing I can do is break up. So this is definitely a decomposition. Sorry about that. Decomposition. Trying to make sure you're awake here. So it breaks up into Al plus N. Of course, that's ionic, so that's solid. That's solid. This gets a 2 because it's in Hofbrinkel. This one must be Mg plus O, but it's never alone, so it gets a 2. Mg's S for solid. Oxygen's a gas. That is solid because it's ionic. And this is a combination reaction because there's one product. This next one must be a decomposition because there's one blank, so there would be one reactant. So Na has a +1, Cl has a -1, and so this is NaCl, solid, and then this would also be a solid, and this would be a gas. You can find the state of matter by looking at the periodic table. Next, we must have another decomposition because it's one reactant. So the only thing it can do is break down. So it's going to break down into Cu solid plus O2, which we know is a gas. C5H12 pentane, I believe, is a liquid. Combine it with oxygen gas. This must be a combustion reaction. And so we know the products are going to be CO2 and H2O. Aluminum combines with chlorine gas. And so Al and Cl are in a new relationship. Al is +3, Cl is -1. And this is going to be a solid, so this is AlCl3. Potassium oxide decomposes. Potassium's a +1, oxygen's a -2, so this would be K2O. And it would be a solid because it's ionic. And if it decomposes, that means it breaks apart into K plus O2. Yes. And methanol, CH3OH, is a liquid. And if it burns, it's combining with oxygen gas. And the products are always CO2 and H2O. All right, that is it.